We are continuing chapter 12, physics. It is a big chapter. There's a lot to learn, a lot of skills. We've covered a lot of ground already on creating physics bodies of different types, dynamic and static, and building little apps where we drop the magic ball and hit stuff. We added irregular shapes last time, including images that had irregular shapes. The next skill I normally teach is more or less of an activity. It is trying to let you guys stack some boxes. And so this teaches two things. You can stack the boxes using a loop, which is the technique I show here in slide 21. So you just put the box setup script inside of a loop. So if you want 6 boxes, you would use a for loop because you know how many you need. So the for loop's the easiest one to use, and you just wrap up all of the box code, setting up the image, placing and sizing it, and adding it to the physics engine. But I normally skip over this approach just because you'd have to code it by hand. Instead, skip to this one, which is uses a timer. And so we've covered timers, no surprise here. The loop will work, but it runs really quickly. And so if you try to add the boxes at one specific location, they would appear on top of each other. And then the physics engine, which is essentially a 2D physics engine, will have to push them apart because you can't have overlapping physics bodies in 2 dimensions. And so when writing it in loop form, you have to be careful, whereas in writing it in a timer, you can make it so that the delay is enough that gravity has pulled the previous box down and it's out of the way. So there is no potential overlap and then potential for the physics engine to shove stuff apart and get some weird, albeit cool results. So the timer is the way we go. So let's do it as a follow along activity if you guys are game. So we're in chapter 12. We're going to create a stack of these lock boxes, and I apologize, I called them, originally these were crates. They were wooden crates that came with Corona, so they were Corona crates. And then I decided I wanted not to use the built-in stuff, leave the built-in stuff for Corona and their tutorials and stuff, so I created an iron box, and then I added a lock to it, so I called it a lock box. So sometimes I call it an iron box, sometimes I call it a lock box, sometimes I call it a steel box, which I guess is an upgrade over an iron box. I don't know why. So please don't be confused. What I mean in any of these is a box. Let's start out by saving this, creating a folder inside of chapter 12. This is stacks and runtime, but you can call it whatever you want. We'll be learning about creating these sort of stacks using timers and the runtime, and I'll call it stack 1. So now I'm going to hunt for this image, and I hope I have it in my resources. There's the lockbox, and there's this beautiful artwork of this highly secure lockbox. It is way too big, certainly. So I'm going to shrink it to something a little smaller. And we need a ground. So to have anything stop before it goes off screen, we'll need something to stop it. And I'll fill it with something. I think we used dirt last time, so I'll go back to a grass color. And then let's add the physics component. So I'm going to head to the physics menu. I'm going to select the lockbox and say add body. I'm going to add it. I'm going to say, okay, I know I need to set up physics, and I'm going to go set up physics. Okay, so I added the physics body for the lockbox. It is object 3. I want it to be dynamic. I want the lockbox to drop under the force of gravity. I'm going to select the ground. I'm going to hit add body. I'm going to add that rectangle, but I'm going to change it to static over here in its settings panel. I'm going to name some stuff because I haven't been good about that yet. So the rectangle is the ground, and the lockbox is the lockbox. So that may not need a separate comment since it's exactly the same as the image file name, but of course you might add image files that are badly named, and it might be helpful to have a simple name to refer to it. So let's save it and run it. We do have a working app. We should have a working app that I covered up Let me relaunch it. So if you're watching, you'll see the box drops. It bounces a couple times and settles there. So if you're following along, you should have, I think you should be at that same level. So, and I'm going to move the lockbox up. That's fine. I want to add a height that I'm going to drop it from, understanding that the higher it is, the more it'll bounce, the more energy in the collision. And when it stacks up with other boxes, the more bounce off the other boxes and such, which I'll need to control to get them to stack nicely. Okay, and then I want a timer. Timers and actions. The button is timer. I want to repeat. Let's just start with 6, 1 per second. I'm going to say that's okay. We'll play around with it. And then here's the timer handler, object 7. Inside the timer handler, I want the image load and the add body for the lockbox. So object 1 and object 3. So I'm going to select object 1 and hit the move image into function. There is only one function, so I don't have to worry. And then I'm going to grab the add body for image 1 and also hit move resource into function, hit OK. And if you're watching the stack, you'll see now the lockboxes are created when the timer fires, and it's going to do that 6 times. You should expect to see one lockbox created and dropping, and then a second, third, fourth, fifth, and sixth. And if we're lucky, they'll stack up on top of each other. If we're unlucky, they'll collide off each other and make a mess. So let's save it. And here we go. Well, so that was interesting. I didn't leave quite enough room for the boxes to stack, so that my lockbox was not really high enough up, or it was sized too large. You'll notice in the screenshot in the keynote, I've made the boxes very small. They did stack just fine though, but if you watch it towards the end, what you'll see is the last two do kind of overlap, and the physics engine shoves them apart. I don't know if you noticed that or not, but these two, when the 6th one it added overlapping the 5th one. And you can't do that, so the physics engine actually shoves it vertically, if you will. Let's watch it again and just watch for that last box. The physics engine's gonna shove it up to keep it 2D instead of 3D. And it's not super important, but that's what happens when you create things as the programmer that overlap in the 2D physics engine. It will shove them apart. So they did stack nicely. So let's play around with that. Let's make this a bit smaller. And let's add a little bounce to it. Default bounce is kind of low. I'll add a little bounce, not a lot, 0.1. And I'm going to decrease friction by 0.1. Let's run and see what happens. So they're still stacking. And you're thinking, he doesn't know what he's talking about. Things just stack easily and automatically. So let's crank it up a little more. Let me also move it up higher so I don't impinge on previous lock boxes. And I'm going to create the timer. I'm going to create a full 10 boxes now instead of 6. And let's work on the settings. A little less dense, a little more bounce, a little less friction. See what that gets us. Oh, there we go. There we go. Did you guys see that? It's a lot of fun. So this is a timer. There's an initial 1 second delay because the timer has that. Whatever your period is, in this case 1 second, the initial run of the timer doesn't start until that 1 second's up. You might notice, or if you pay attention to how this ended up, and we run it again, it might not end up the exact same way. So there's enough randomness or whatever in the physics engine that you won't necessarily get the same end state. There's just enough either randomness or imprecision that the way things bounce and the way things slide and the exact timing, there's enough difference that even with the same starting situation and the exact same settings, you might not get the precise same end product. You could do, again, the same thing with the loop, but let me simulate that just really quickly. I'm going to move the lockbox back to the center. I'm going to change the timer to run essentially without delay. I'll give it 1 millisecond. So that's as fast as the loop is going to run. So what that means is it's going to add them and they're going to overlap immediately. And then the physics engine is going to have to shove them apart immediately. So we totally missed that because the delay of 1 millisecond was too quick for me to switch, and I don't have enough recording area really to get everything. But you see, it's almost like a stack of cards, and they all show up, and then the physics engine goes to work and tries to shove everything sideways. All right. And so the activity, if you want to play around with it, is to just see how many of these you can stack. And you don't have to sabotage it with bad friction settings and stuff, but at some point, if there's any bounce in the stack, when the new lockbox falls on it, the stack will bounce just enough to start it sliding sideways and falling apart. Okay, the next activity is similar, but now it uses our skill with using a timer to drop stuff. So I'm going to create a stack of 6 lockboxes. I'm going to drop that iron wedge in the corner there, and then I'm going to use another timer to drop 10 magic balls. And so the magic balls will each hit the wedge, ricochet off into the tower of lockboxes, and try to knock it over. It's up to you to make the settings of the magic ball. If you set them so that they're quite dense, and the lockboxes are less so, then when the magic ball hits the stack, it'll kind of obliterate it. But the default settings, I don't think they will. But let's do it and figure that out. I'm going to keep using this example so I don't have to start over. I need six lockboxes, but if you want to start over, if you want to do a save as now, so that you have this one example, saved, you certainly are welcome to do that. So I'm going to, well, for fun, I'm going to drop everything from the top of the screen. I am going to fix some of the issues. So the bounce I'm putting back to 0.3, putting the friction back up close to 0.3. Density's fine the way it is. I'm going to change this timer so that it only runs 6 times to drop the 6 boxes, and I'm going to make everything drop 1 per second. So that should give me a stack of 6 iron boxes, 6 lock boxes right here. I need the wedge, so let's find the image for that. I'm going to load it as an image. I'm going to look for it in documents, resources, images, iron wedge. There we go. So the iron wedge is huge. We will want to resize it and play with it. So let's start with resize it to scale. And I normally scrunch it vertically a little bit, so it's more like that. And you could keep it like this and ricochet off of it, or we could rotate it, make it look like the screenshot in the keynote. So I'm going to add a new snippet. And I'm going to call it rotate iron wedge. Is that what I called it? What's important is it is object 9. So I'm going to say object 9.rotation. I'm going to have to spell rotation correctly. And let's rotate it 90 degrees and see what that gets us. I need to add it as a physics body. That's the thing I forgot, actually. So I'm going to select the image, head back over to my physics palette, say add body, and we could drop it and let it bounce and settle where it settles. We could pre-place it where it goes and make it static so it stays put. Let's start by just adding the body and seeing if it bounces off the screen, badly or something. I will decrease the bounce quite a bit and increase the friction quite a bit. And I'm going to increase the density. So hopefully it will drop and settle very quickly so that when the balls hit it, it's not still bouncing. And hopefully it won't slide off screen easily now when the balls start hitting it. I'm going to save it though because we've added a lot of stuff and I want to test it. So I turned it the wrong way. But I've got my 6 boxes. I'm going to change the syntax to minus 90 then, because apparently I misremembered how the rotation works. And it settles a little bit far to the left, so I'm just going to move it. But I really want it to settle just like the screenshot. Let's try this. That's pretty good. It is a little tall, isn't it? All right. Now we need the balls. I'm just going to use another timer, and I'm going to drop 10 balls. So I'm going to head to Actions. I'm going to create another timer. I'm going to repeat it 10 times. I want to load the magic ball. So I'm going to head to Display Objects, Image, and look for the magic ball. All right, maybe I don't have anything else here. I'm going to put the ball up here. I'm going to shrink it a little bit. All right, I'm going to line it up so I think it'll drop and hit that ramp nicely. And then I'm going to add it as a physics body. So I'm heading back to physics, saying add body, selecting the magic ball, and then I'm going to move object 16 and object 17 into this second timer, object 13 on timer handler. So selecting the image, I'm going to hit move image into function. Now I do need to check because now I have two functions in my stack. I want the second one, the newer one, object 13 on timer handler. Same thing with the add body, move into function, select on 13 on timer handler, object 13 on timer handler, say OK. Let's save it, see what we got. All right, so it's not working great. And so let me just ask, why do you think it's not working great? And what do you think the solution is? Yeah, the physics shape or mask is off. And so before we fix it, let's verify that it's off. We'll go to Setup Physics. Anytime you see something on screen in physics that isn't working like we want, like how is this ball halfway into the ground? How are they overlapping like this? You said it was a 2D engine, you can't have overlap, and yet they are overlapping. Anytime you get that, change physics mode to hybrid, save it, and then let's watch what happens. Yeah, so if you look closely, you'll see the physics shape for the ball is this half circle. That is not what we want. The physics shape can be fixed by heading to the add body for the magic ball and changing it from use generated outline to use circle. Hit the resync button to update that, and then let's run it again. So the ball, that's interesting, the way I coded it, the balls are hitting the stack before the stack can fully form. So I'm going to tweak this a little bit, and for the second timer, I'm going to give it another 2 seconds so that a couple more iron boxes can hopefully have landed and settled. Still not enough. So with the default settings, clearly the balls are more than a match for the lock boxes, but of course we've coded it so that the balls have the same default density as the iron lock boxes, which is not the case. So if we wanted to make it a little bit more realistic, we would head to the add body for the ball, probably take away some of its density, and balls should be bouncier certainly. So let's add some bounce as well. All right, and I'll take it off a hybrid and run it one more time so that you see it. So now we'll see if the if the successive strikes of the magic balls are enough to knock it over, they're not really hitting it with a lot of energy. I don't think they're going to do it. I think they're going to do it. All right, one more tweak and turning off hybrid. And let's tweak the balls a little bit more. So maybe I took away a little too much density. Certainly, they're still not very bouncy. Let's give it back some density. See what happens. So these are fun to play around with. You can set up your own little physics world, and I've clearly overdone it. Now the balls are way more than a match for the puny iron lock boxes. And in fact, the balls are now shoving the very dense ramp, and it'll probably get shoved off screen. If it gets hit again, it'll go off screen, but actually now it looks like the way it's settled, all the balls are just going to bounce off screen. All right. All right. The next topic up is the runtime object. So, or it technically is a table in Solr 2D. In Draw Code, it's a runtime script object. So the idea is that runtime gives you access to the app as it's running, kind of implied by the name runtime. But what does that mean? If you have access to runtime, you can add listeners to it. You can add lots of listeners to it. For instance, you could add the tap listener to the runtime, and then you'd track taps anywhere on screen because you weren't adding the runtime, say, to a particular polygon like we did last time, the down arrow. So as an example, what if you wanted, in the app, you wanted the user to be able to tap and drop a magic ball instead of using a timer? I mean, the timer was fun, but what if you wanted to make the ball more interactive, the app more interactive? You could add a runtime and do that. So let's do that. We're going to start step one just by adding the runtime and seeing what it does. And so this step is tough. You got to really concentrate. I'm going to push this button. Click. And so I'm going to add tap to it so that we can play around with tap first. So there's nothing on screen for the runtime. The runtime doesn't have any visual analog in the design. So you just select it in the stack to get its settings panel here, the details panel. Say add listener, and you can add all of these listeners, but we're going to do tap. So I selected tap. I'm going to say OK. Now I'm going to save it. The app works exactly the same as it did previously, but if you tap, what you'll see is where you tap will be reported at the console. So it's giving you the XY location where the user's finger tapped, or in this case where our mouse is tapping. Again, with the 0, 0 point up at the top left corner, so that it works. It doesn't do anything. All right, so what we're going to do is replace the timer as the way to drop the magic balls and replace it with the tap handler. So we're going to put those two script objects, we're going to move them from the on timer event handler into the on tap for that object. Here's my on tap, here's my on timer handler. I want to move these out of on timer handler into on tap. So I'm going to move the resource out of this function. I'm going to do it with both of them. And now I'm going to move them into on tap. I'm just selecting them and hitting move into function and selecting on tap. Got them out of order. I have the add body before the image. That won't work. You can't add a body before you have an image to add. So you've got to load your image first, then add it as a physics body, or create your display object first and then add it as a physics body, not the other way around. I can now get rid of this 10 repetition timer. So I can pull it out of the code. I could delete it. I'm just going to pull it out of the code. That's actually out as well, but see what this looks like. Okay, so I've waited the 3 seconds. There are no magic balls. They should drop when I tap. Where I tap is the next step. But this, I can use this to give me a much more kind of violent set of balls to knock the tower off screen. Sorry, here's the stack if you're trying to follow along. Again, all I did was I moved what was in on13 timer handler and put it in on tap, so that now when the user taps anywhere on the screen, a magic ball is added and then added as a physics body, which causes it to drop. Okay, the next activity we'll do together is change it so that the ball drops where I tap. I mean, it's a skill you already kind of know how to do. We know the image is created, and when it's created, it's placed at an XY location. By default, it's placed where I've placed it on screen. But I can use a snippet. I can use a snippet to override that. So let's add a snippet. Heading to snippets, hitting add snippet. I want to move it into on tap. So I'm going to hit the button, move into function, select on tap, hit OK. And I'm going to move it up so that it's directly below the image script object. So the image is loaded here, right after it. Now I want to change its XY location. I'm going to call the snippet reposition ball to tap location. Sorry, the trash truck is here. All right, here's that snippet. The image is object 16. So I know, for instance, to set, here's a comment, reposition. So I know I need to work with object 16. I want to change its x. So I'm going to change it to event.x. And I want to change its y equals event.y. So all I'm doing here is saying, although the ball is created here, I want it moved to the tap location before it's added as a physics body. So wherever I tap, it'll be as if the ball had started from that location. Then it will be added to the physics engine and drop from that location. All right, let's save it. You might have already done this. Here's the boxes. No balls. We've waited there 3 seconds. There's no balls. That timer's commented out, so it's not going to work. But now when I tap, I should get a ball where I tap. So this makes the game, way more interesting. Also, I'm not limited to 10 balls. There's no limit in here at all. So if I can't get those boxes, with 10 balls, I can just keep tapping and adding an insurmountable amount of magic balls so that the tower has no choice but to collapse. And we're so close, let's spend another 2 minutes and talk about interframe. Okay, we have access, once we have a runtime, we have access to another listener that's new to us called interframe. And interframe gives us access to the app as it runs at its current frame rate, which defaults to 30 times per second. So we can do stuff in interframe. We can do lots of stuff in interframe. Any game you write will use interframe extensively. So let's add it and see what it's like first. Okay, I'm going to close that, and I'm going to select the runtime. I'm going to say add listener, and I'm going to select interframe. I could alphabetize them, but I think I've added them in the order of things that we do via examples in the book. So we'll use it for collisions next time, and tap and touch as well, and much less these. Okay, but I want interframe. That was the default. Now I get a new function on interframe. So this will, by default, not do anything, because if I do anything like even print something out to the console, it'll be printed out to the console 30 times a second. So you'll just get this mass dump of information out of the console, and it makes it impossible then to see stuff like where you tapped. If you were hoping to also look and see where you tapped, it'd whiz by in the console so quickly you'd never see it. So that's why I've got all this in here, but I have it all commented out. You can comment in all of this stuff. And so you might have noticed as I was doing it, I had double comments here on this comment. Just because when I had single comments, lots of students would undo the comment, and that would make Solo2D think that was a line of code, and it's not, and then they couldn't run their app. So I added a second set of comments so that you can uncomment it, and it still is a comment. Please don't uncomment it twice. That will break it. And then I've got this snippet here that was also added. If you look at the snippet and zoom in on it, what you'll see is there's a comment, and then there's this commented out variable initialization. So if you want to do what I'm doing, you'll comment that back in and then save it. And what we should see is sort of this heartbeat. If you watch it as the game is running, you're getting information about the timer firing 6 times, but then every second you're getting this, it's been a second, it's been a second, it's been a second, kind of heartbeat. And you could use that to do anything. For instance, you could program it fairly easily so that if the tower got knocked down, that you started it over. You would just check, maybe every second, maybe more often, to see if the Y location of all the lock boxes is now below 480, greater than 480, something like that. Anything you wanted to do. If there was a scoring system, you could update the score on screen intermittently via interframe. And when we make games with platforms that move around, we will use interframe to slide a platform left and right, or an elevator up and down, or to rotate something. So let's rotate something just because it's kind of fun. Let me change this to kinematic, which should keep it hanging there. I'm going to comment this out just because I don't need it, but I'm going to need this basic code, so I'm going to copy it. I'm going to pull it out. I'm going to head into my inner frame where I already have this snippet. I even have it open. And so I'm going to try to paste the code. If I can hit the right keystrokes, I'm going to try to paste the code there. But I'm actually going to make it more math-y. I think I need to say object9.rotation equals object9.rotation minus 90. Let's see what that does. I did not practice this step. It just came to me as an epiphany that it would be fun. There we go. So if you're following along, what you'll see is now the game's harder, because there's this like ticking clock that's changing the iron ramp, the rotation. So this code is running 30 times a second, but it's keeping track of the time, and it's waiting a second, which is 1,000 milliseconds. And then every 1,000 milliseconds, I do stuff. I update the last time it did it so that this keeps working, but then anything else I want to do once per second, I would put in here. And so if you don't want it once a second, you want once every half second, then you change that number. It's that easy. All right, I think I just talked through all this without having the slide, but that was because we were in Draw to Code. I was in Draw to Code doing it at the time, but this summarizes, I think, everything that I said. That covers what I wanted to get to today. You now have a ton of skill. We've added little by little, but you've actually got to the point where you can make some kind of cool little games, I think. We will finish out the chapter next time. Just to give you a preview, we're going to do moving platform, simple moving shelf, and then we do this wild one with all sorts of moving stuff on screen at once. And then there's activity where I've essentially started a little game for you, and I'll let you guys create a platform that'll lift the magic ball up and move it across the pit of lava down here, and then knock it into the exit. You can do that with one platform that takes it the whole way if you want to, Or you can do it with a sequence of platforms. You can raise the ball up onto a platform that's moving like this, that drops it here, lets it rolls off, and then you can have a platform here that comes up and knocks it in. If you want to be thinking about strategies, that'll be the activity next time.